What is the meaning of double displacement reaction? So double displacement reaction is nothing but a chemical reaction in which there is an exchange of radicals between two ionic compounds is called as double displacement reaction. Okay, double displacement reaction is nothing but which there is an exchange of radicals between two ionic compounds are called as double displacement reaction. So now we will understand about this double displacement reaction with one activity. Double displacement reaction. Take a pinch of lead nitrate. Take a pinch of lead nitrate and dissolve in 5.0 ml of distilled water in a test tube. Okay, take a pinch of lead nitrate and dissolve in 5.0 ml of distilled water in a test tube. Okay, now take a pinch of potassium iodide in test tube and dissolve in distilled water. Next, take a pinch of potassium iodide in test tube and dissolve it in distilled water. Okay, what we took? We took a pinch of lead nitrate and we dissolved it in 5.0 ml of distilled water in one test tube, and after that we took a pinch of potassium iodide in a test tube and we dissolve it in distilled water. Now mix lead nitrate solution with potassium iodide solution. Next, mix lead nitrate solution with potassium iodide solution. So what happened? Mix lead nitrate solution and potassium iodide solution. What happened? What do you observe? A yellow colored substance which is insoluble in water is formed as precipitate. This precipitate is lead iodide. This precipitate is lead iodide. Okay, first we took a pinch of lead nitrate and we dissolved it in 5 ml of distilled water. After that we took a pinch of potassium iodide in a test tube and we dissolved it in distilled water, and we mixed that lead nitrate solution with potassium iodide solution. What happened when we mix this lead nitrate and potassium iodide solution? A yellow colored substance which is insoluble in water, it was formed as precipitate. A yellow colored substance which is insoluble in water is formed as precipitate. This precipitate is lead iodide. Okay, yellow colored substance is formed now, that is insoluble in water, that is called as precipitate. That precipitate is lead iodide. Okay, so lead nitrate PbNO3 formula. Okay, lead nitrate plus potassium iodide. We took these two only, no, this lead nitrate and potassium iodide combining, and it will form lead iodide and KNO3, means lead nitrate and potassium iodide. These two we are mixed and it will form lead iodide and potassium nitrate. Okay, lead nitrate and potassium iodide we took and we added these two, and we observed that in one yellow colored substance that is insoluble in water was formed. This precipitate is nothing but lead iodide. Okay, so lead nitrate plus potassium iodide gives rise lead iodide potassium nitrate will form. Okay, these are the reactants. Okay, lead iodide and potassium nitrate as the products. Okay, lead nitrate PbNO3, potassium iodide Ki, these are the reactants. And which products are formed? Lead iodide and KNO3, these are the products. Means here the both reactants are exchanging its constituents or not? Yes, means lead nitrate PbNO3 plus potassium iodide Ki. So this lead nitrate form lead iodide, potassium iodide form potassium nitrate. Okay, once you observe the equation in your textbook. Okay, lead nitrate and potassium iodide are the reactants, lead iodide and potassium nitrates are the products. Okay, lead nitrate and potassium iodide are the reactants, lead iodide and potassium nitrate are the reactants. Okay, so here this both reactants exchanging its constituents or not? Yes, exchanged. So in the place of lead nitrate what came? lead iodide came. In the place of potassium iodide, what came? Potassium nitrate came. So both constituents are both reactants are exchanging its constituents. Okay. So here the yellow colored substance which is insoluble in water is formed now, that is called as precipitate. That is called as precipitate. That is lead iodide. Okay. Yellow colored substance which is formed is yellow colored substance which is insoluble in water is formed now, that is called as lead iodide. Okay. A yellow colored substance which is insoluble in water, it was formed is nothing but lead iodide. Okay, that is lead iodide, that is called as precipitate. Okay, here both the reactants are exchanging its constituents, no, that's why it is called as double displacement reaction. Okay, double displacement will take place, that's why it is called as double displacement reaction. This reaction is double displacement reaction. Why? Because if two reactants exchanging their constituents chemically and form two products, okay, then the reaction is called as double displacement reaction. Other example for double displacement reactions are sodium sulfate solution on mixing with barium chloride. Sodium sulfate solution on mixing with barium chloride solution, it form a white precipitate of barium sulfate. So and the soluble sodium chloride. Okay, so one more example for double displacement reaction is nothing but sodium sulfate on mixing with barium chloride solution. Sodium sulfate on mixing with barium chloride solution, it form a white precipitate of barium sulfate and soluble sodium chloride. Okay, when the sodium sulfate is mixing with barium chloride, it form white precipitate, that is barium sulfate and sodium chloride. Okay, so formula of that sodium sulfate NaTS4, formula of barium chloride BaCl2, it will form barium sulfate and sodium chloride. Next, one more example is sodium hydroxide react with hydrochloric acid. Sodium hydroxide react with hydrochloric acid to form sodium chloride and water. Sodium hydroxide formula NaOH. It is reacting with hydrochloric acid HCl. It will form sodium chloride and H2O. Okay, this is also one of the example for double displacement reaction. Sodium chloride spontaneously combined with silver nitrate solution. Sodium chloride spontaneously combined with silver nitrate in solution by giving a silver chloride precipitate and sodium nitrate. Sodium chloride, when it is combining with silver nitrate, it will form silver chloride and sodium nitrate. This silver chloride also one of the example for precipitate. Okay, so it is one of the example. Okay, we will discuss about oxidation and reduction reaction. So what is the meaning of oxidation and reduction? Now we will discuss. Oxidation is a reaction that involves in addition of oxygen and removal of hydrogen. Okay, so what is the meaning of oxidation reaction? Oxidation is nothing but that is a reaction that involves in the addition of oxygen and removal of hydrogen. If in a reaction if the oxygen is added, then we can call that reaction as a oxidation reaction. Okay, what is the meaning of reduction reaction? Reduction is a reaction that involves the addition of hydrogen or removal of oxygen. If in a reaction, if the oxygen is removing, okay, and hydrogen is added, we can call that reaction as a reduction reaction. Okay, so what is the meaning of oxidation and reduction? One more time I will say, oxidation is nothing but if in a reaction if the oxygen is added. Okay, oxidation is a reaction that involves the addition of oxygen or removal of hydrogen. So oxidation is nothing but addition of oxygen or loss of hydrogens or loss of electrons. This type of reaction is called as oxidation reaction. Oxidation is nothing but addition of oxygen or loss of hydrogen or loss of electrons, that is called as oxidation reaction. What is the meaning of reduction reaction? Reduction reaction is nothing but loss of oxygen or gain of hydrogen or gain of electrons. Okay, reduction reaction is nothing but loss of oxygen or gain of hydrogen or gain of electron. This reaction is called as reduction reaction. Okay, so reduction is a reaction that involves the addition of hydrogen or electrons or removal of oxygen. Let us try to understand more clearly doing this experiment. Okay, now we will discuss about this oxidation and reaction with the help of experiments very clearly. What are that? See here. Take above 1.0 grams of copper powder in a china dish. Okay, so take above 1.0 grams of copper powder in a china dish. Keep this china dish on a tripod stand containing wire gauge. Okay, first take 1.0 grams of copper powder in a china dish and keep the china dish on a tripod stand which is containing wire gauge. Okay, once you see the figure, in that what we took? In that we took copper powder in that china dish. Okay, that white color bowl is nothing but china dish. This china dish we are using in the laboratory. So in that china dish we took copper powder. Okay, now keep this china dish on a tripod stand. These three rods like there, no, that is nothing but tripod stand. On the tripod stand we kept wire gauge. Wire gauge we kept. Okay, keep the china dish on a tripod stand containing wire gauge. Next, heat this china dish with the help of Bunsen burner or with a spirit lamp. Okay, heat this china dish which is contain copper powder which is kept on the tripod stand with the help of Bunsen burner or spirit lamp. Do you find any change in the color of the copper? Yes, we can observe change in the color of a copper. We will notice that the surface layer of a copper becomes black. Okay, we can observe that the surface layer of a copper becomes black. Why does the color of a copper change? What is the black color product formed on the surface of a copper? Okay, so here we can notice that the sulfur layer of a copper becomes black. And why does the color of a copper changes? What is the black color product formed on the surface of a water? In the activity on heating copper, it is reactive with oxygen present in the atmosphere to form copper oxide. So in this activity on heating the copper, it is reactive with the oxygen present in the atmosphere and form copper oxide. Okay. So when we place this china dish with copper powder on the Bunsen burner, the surface layer of a copper becomes black. No, so why it is becomes black? Why the color of a copper changes? What is the black color product is formed on that? So here when we place the copper powder which is in the china dish on the Bunsen burner, then what happened? When we are we place the china dish with copper powder on the tripod stand, means we are heating. Okay, on heating the copper powder, it is reacting with the oxygen present in the atmosphere. It is reacting with the oxygen present in the atmosphere and it forms copper oxide copper oxide. Okay, what is the reaction for this? 2Cu plus O2 gives rise to CuO. Okay, so when we place this copper, it is reacting with the oxygen present in the atmosphere and that color of the copper sulfate is changing. That means copper is combining with the oxygen present in the atmosphere and it will form copper oxide. Okay, 2Cu plus O2 gives 2Cu. Next, here copper oxide combining with the oxygen to form copper oxide. No, yes or no? Yes, copper is combining with the oxygen to form copper oxide. So here oxygen is gained. Here the oxygen is gained. That's why this process is called as oxidation. Okay, so copper is combining with oxygen present in the atmosphere. Copper is combining with the oxygen present in the atmosphere. It will form copper oxide. No, means here the oxygen is added to the copper, means oxygen is gained, means oxygen is added to the copper, that form copper oxide. So it is one of the example for oxidation reaction. Next, now pass the hydrogen gas over the hot copper oxide obtained in the activity and observe the change. Okay, now pass the hydrogen gas over the hot copper oxide obtained in this activity. So take hydrogen gas, pass the hydrogen gas through the hot copper oxide that is obtained in the above activity. Observe the change. What do you notice? So is there any change in the black color of the copper oxide? Okay, so here one glass tube is there. No, once you see that glass tube, in that glass tube middle we kept copper oxide. Okay, and we close the ends of the glass tube with the help of single hole rubber cork, and we kept uh, glass tubes in that. So from that, from one end of the glass tube we have to pass the hydrogen gas. Okay, once you observe left side of the glass tube means we are passing hydrogen gas. Then what happened? Is there any change in the color of the black colored copper oxide powder? From one end of this rubber cork we are passing the hydrogen gas. So then is there any change in the color of the black colored copper oxide powder? Yes, you will notice that black coating on a copper turns to brown because copper oxide loses oxygen to form copper. Okay, here we can observe that black coating on a copper changes to brown color because this copper oxide loses oxygen and form copper. In this process oxygen is lost. Okay, in this process oxygen is lost. So this process is called as reaction. Okay, when we took this copper oxide powder in a glass tube, when we pass the hydrogen gas, then what happened? When we heat with Bunsen burner, when we pass the hydrogen gas, the black color coating on the copper oxide is disappear. It is changing into brown color. Why like that? Why? Because here this copper oxide, when we pass the hydrogen, copper oxide lose the oxygen from its compound. So in this reaction oxygen is lost, means in this reaction oxygen is lost. No, so this is one of the example for reduction reaction. Okay, CuO copper oxide plus H2 means we took copper oxide and we pass H2 gas. So then what happened? Black color disappear, brown color solution will form, means H2 will form, Cu will form. Okay, CuO plus H2, we took copper oxide and we added H2. So copper oxide lose oxygen. No, copper oxide lose oxygen, so remaining what will be there in that? Copper only there. Cu plus H2O it will form. In the above reaction hydrogen is gained. In the above reaction hydrogen is gained. Okay, in the above reaction hydrogen is gained, oxygen is loose. Such reaction is called as reduction reaction. In the above reaction hydrogen is gained and okay, hydrogen is gained, oxygen is loose. In the above reaction hydrogen is gained and oxygen is loose. So in this reaction hydrogen is gained and oxygen is loose. Such reaction is called as reduction reaction. Okay, generally oxidation and reduction reactions occurs in same reaction. Sometimes oxidation and reduction reactions occur in same reaction. In that if one reactants get oxidized but other gets reduced, such reactions are called as oxidation reduction reactions. So generally we can observe the oxidation and reduction reactions in same reactions. So in that one of the reactants get oxidized, another reactants get reduced. These type of reactions are called as oxidation reduction reactions or redox reactions. Okay, in the CuO H2 reactions CuO is reduced. Okay, in the CuO and H2 reaction CuO is reduced, H2 is oxidized. Okay, so CuO copper oxide, that CuO is reduced, H2 is oxidized, means in CuO oxygen is loose. Okay, in H2 oxygen H2 it will form, okay, copper oxide powder we took, H2 gas, copper oxide powder we took in glass tube, and H2 gas we send. In that CuO lose oxygen, means CuO lose oxygen means, okay, in the glass tube we took copper oxide powder, okay. So in glass tube we took CuO, copper oxide, and we pass the H2 gas. In that copper oxide lose oxygen, black color of the copper oxide changing into brown color, means copper oxide lose oxygen, means oxygen is losing, no, that is reduction reaction. Oxygen is losing, reduction reaction. H2 took oxygen, yes or no? H2 took oxygen, form H2O, means in one equation is there, no, CuO plus H2 gives us Cu plus H2O. CuO lose oxygen, H2 gain oxygen. CuO lose oxygen, so Cu is there. H2 gain oxygen, so oxygen is there, okay. So CuO lose oxygen means losing oxygen, means that is reduction reaction. And H2 gain oxygen, H2O formed, gaining oxygen means oxidation reaction. So sometimes oxidation and reduction reactions are takes place in the same reaction. Such type of reactions are called redox reactions or oxidation reduction reactions.